Welcome to a presentation about ionic radius. Ionic radius is the atomic radius of an ion. Ions are atoms with a positive or negative charge. Since atoms have an unchanging amount of protons and neutrons, ions can only be created when electrons either gained or lost. Uh, there are two types of ions. One would be a cation. If you look here, there's an atom with 3 protons and 3 electrons, and there's Coulombic force holding the electrons into it. If there's enough ionization energy to counteract that force, then you can remove the electron from the atom, creating an ion. This type of ion would be a cation because it has 3 protons, which all have positive charge, and 2 electrons, which have negative charge. And the charge would be positive, which is what a cation is, an ion with a positive charge. Here's another atom here. Like the other one, it has 3 electrons and 3 protons. And if we do the same thing, we counteract the Coulombic force, it'll lose one. But we don't want to do that. We want to gain one. So when atoms interact, they tend to either take or gain electrons. And here this one gains one. So now it has 4 electrons and 3 protons, and it has a negative charge because the electrons outnumber it. This is known as an anion with a negative charge. There are two types. Now, if you look at atomic radius, we'll know that it is half the distance between the nuclei of 2 atoms of the same element. So if you think about it, for ionic radius, it would be the same except for an ion. So if you look at the periodic table, we'll note some trends given the similarity and characteristics by the way it is arranged. So if we go down, we'll note that they have the same number of valence electrons given that they're in the same family, but there'll be in one higher energy level. So for the alkali metals, lithium has 2 energy levels in 1 valence electron, and sodium has 3 energy levels, but also 1 valence electron. So going down, the Coulombic force is lessening, and the valence electrons are farther away from the nucleus. So if we were to move one, it would move down one, but they'd still be farther away from the nucleus. Therefore, the atom would be large. The atom or ion, which we're dealing with now, would be larger, and that's for every single column / group. If we go across a period, it's a little bit trickier because the trend is the same, but the reasons are different, and that's all to do with what the element is. If it's a metal, it'll always form cations. If it's a nonmetal, to the right of this black line, it'll always form anions, and that's due to their electronegativity and the way they interact with other atoms. These will always gain electrons, these will lose electrons. So going across, they always, whether nonmetal or metal, they will always lose. It just depends on depends on the relativity to the atomic radius in size. So lithium and beryllium, it'll be decreasing because you'll need to remove more valence electrons to go down an energy level, but therefore there's more Coulombic force going this way, and the atoms held more closely together. So remove an ion, it's still held more closely. Remove an electron, it's still held more closely together, but now it's an ion. So it would continue like that until boron, which is a nonmetal, where it would jolt up because anions, which all nonmetals form, always have a radius larger than the atomic radius, because when they gain electrons, the electrons repulse and they move farther apart. So by gaining more electrons, they're repelling even more, making them farther away from the nucleus. So with boron, it has 5 electrons in its normal state and 5 protons. The maximum amount of electrons would be 10, and then it's in the second energy level, so we remove the first 2, and then we have 3 valence electrons. So we can add we can add 5 more electrons, and then we'll have completed the energy level. So then that's 5 electrons that more of repulsion, so that's larger. But that's with here where we have 4, that's 1 less all the way to here. So that'll slowly start decreasing. So if we look over here, we can talk about more about why that is. So if we have here an atom with 4 valence electrons. So it'll have an ionic radius of about that much, because if we had another atom here, that would this right here where they meet would be half the distance. But let's say we remove an electron. And then we keep removing electrons. It's an ion. It's a cation, but it's down at energy level. So we reduce that. So you can see how the ionic radius is smaller for cations, like all the metals that were on the left side. Now over here, we have one with 6, and we can only add 2 more. So if we add, if we add 2 more, we'll be adding 2 more electrons worth of repulsion away from the nucleus. So since they're all, like, if you have 2 magnets and you hold them together, they move apart, and the more, so let's say we added 2 magnets to 6 magnets, they'd be pulling apart more. So this would get a little bit bigger. But let's say we had 4. There would be less total repulsion, so they'd be closer together. But so then when we add 4 more, it may be back to the size that the other one was, but the overall difference will have increased. So if we look back at the periodic table, we'll note that the one with 4 was carbon, so it could add 4, so it could have an overall difference between atomic radius and ionic radius of much larger. But if you go down to oxygen, which was the one with 6, you can only add 2, though this may be like the same size, the difference would be smaller. Thank you for watching the video.